Yeah.
Yes, you are
Okay,
presented,
perfect.
and we can see your screen. Please go ahead.
Okay, perfect. So in the background, you already see ShieldX running. This is the management console. And as Ratinder mentioned, this is the only VM, the only thing you need to ever manage. ShieldX itself has a lot of other VMs and microservices built in, but they all deployed automatically behind the scenes depending on your security intent. And they contain the malware detection, URL classification, intrusion prevention, anomaly detection, and the so-called indicator of pivot, as we call it, that shows you the current threat against your data centers. So I'm just executing here a small test virus transfer from one of our workloads in the data center to another. And in the background, you just saw that the malware count went up. So this shows you that malware detection is happening live in that system. And so for this to set up, there's only three major steps, to be done. So the first thing after you start off with the initial VM that manages all the environments is to create the so-called infrastructure connectors. And those connectors can now go into VMware, into Azure, into AWS. And what we would need for those is just credentials into those environments. And then this initial discovery is going to start. So after that initial discovery, you can decide how you want to insert and how you want to group into these environments. So you have the ability to create groups that span across multiple environments or that are specific to one environment. So if I go into one of those environments, you can now, you see that you can create groups based on either networks or based on workloads. And the groups can now be so-called intent-driven. So they can be specified by calling out criteria for a network or criteria for workloads. And if you, for example, have tags in your data centers, you can create a tag-based network group, tag-based group that will automatically insert the right set of security controls no matter in which environment these workloads show up. So we are really binding now the security controls to the environments or to the workloads rather than to the environments. And in this case, I have shown you here a couple of network-based groups. You can add additional groups by very easily by creating those rules. And you have the ability to create them either in passive mode or in inline mode or in micro-segmentation mode. Or you can also create groups that exclude the insertions. So that means never go and insert another security control in there. But if you have very broad, very large networks, you could create a single insertion rule and then have multiple other rules that group objects that are already in the same larger network. So let me go ahead and maybe flip the insertion mode for that workload that I've shown you earlier from the current tab insertion to an inline insertion. And then I can show you how we can block the malware transfer that I've tried earlier. And you see here there's a tag-based group. And this tag-based group is based on based on the ShieldX tags. And I can easily flip now from tab to microsegmentation, and then every traffic that goes between VMs, even if they are on the same subnet, is going to go through a set of security controls that we define. And this insertion can happen without disruption. So we just inserted into a couple of data centers of a law firm. This law firm had SQL databases, document stores, and other things that were very critical for their operation. And they could really insert into that traffic without causing an outage. And when we deploy, we can deploy in high availability mode, which means if you want to even upgrade our solution, there's live upgrades that replace these microservices one by one. So you have rolling upgrades that allow you to have upgrades without really calling for an outage. And in this case, there's 4 workloads in the same group. They're all tagged with this shark tag, and the group definition specifies that the grouping tag should be this shark tag. And if I now go and microsegment that, the next step is that this shows up in insertion staging. So you can stage multiple of those changes together, and then you can commit all those changes at once. And those changes will now be applied through a job. And this job is run by the ShieldX orchestration engine. And this orchestration engine now is, first of all, it's cloud agnostic. So no matter if you are in AWS, in ESX, or in any other environment, it runs behind the scenes. It knows what tasks to accomplish to realize your security intent. And once that is done, the intent is kept up to date as well. So we have another concept which we call the continuous discovery. And this continuous discovery allows us to continuously react to changes as your data center changes. So let me quickly pause here for a second and see if there's any questions on the insertion of security controls. And if not, then we can jump into the next couple of discussions around visualization of discovery and security controls themselves. Any questions so far?
Nothing from my side.
Okay, perfect. So what you see here is actually the number of steps you would have to go through to realize your security intent manually. So these are hundreds of steps typically, and that also shows you the ROI of the product as it continuously updates and continuously runs those jobs and tasks for you. So once you're inserted into that environment, you also get visibility. And visibility leads to a connectivity view where you can see which VM is talking to which other VM, or which network component is talking to which other network component. This can also be a CIDR, a laptop talking into your data center, some IoT device, or maybe a FAS, something that is communicating with those workloads, and we are showing those as a map on a map of connectivity inside your multi-cloud environment, and that also formulates the basis for defining your security policy. And the connections looks like it's a little slow here, so it will take a couple of seconds to refresh on the screen. But you'll see how each individual microservice, each individual VM is talking to each other VM, including which services they are using, and eventually the view that we are going to build up is something like this. So you see here different applications talking to each other, and with our machine learning classification, you are going to see now that there is a three-tiered application in this case called flights, and there's a web server, a certain set of web servers that formulate the web tier. There's a business logic tier and a database tier, and each of those individual VMs need a certain set of ACL rules for them to facilitate communication between them. And then the other thing we are discovering is actually the vulnerabilities that they are susceptible to, as well as also the attempted exploitations of those security vulnerabilities. So this is now a small workflow that allows you to implement ACLs and implement the so-called zero trust policy for your data center. And as Tina mentioned, there's a machine learning algorithm behind this that helps you with this, because just the sheer fact of showing visibility and showing the connectivity map doesn't help you in implementing policy very much, because there's a lot of connections. There's tons of VMs coming up and down all the time, and it is very hard to understand and manage that connectivity, and it's constantly changing. So what we are saying is, with that workflow, that 5-step workflow here, we are going to help you drive the access control, the right set of access control definitions that leads to a very concise security policy.
Hi, Manuel. Where do we see the drill down view of the individual resources that make up the layers? So for your database layer, web application layer, as we saw on the previous screen, where's the individual view? Like if we join an AWS account, is there a place where we can see all our AWS resources, which accounts they belong to, and the respective like configs of each resources, that type of thing?
Yeah. So this is a different view. In this case, I have only 2 environments. So I have an Azure view that has different VMs, and there we show you different IP addresses. And if you click deeper into this, you see also additional information about those VMs. So you get a basic discovery view first, and then you can decide which ACLs you want to group them into, and which tiers they will represent, and that leads to this view. And this view then is the business application view, and after that business application view is defined, you can then also define additional security controls, like what we've shown here, what I'm showing here in a second. So, 1 second. And this takes a couple of seconds to refresh. It looks like the connection is not the fastest one, but there's a so-called policy sets that you can apply, and these security policy sets consist of one of each policy types. And so if you look at, for example, the threat policy, we currently have about 13,000 threats we cover today. And for these, there's about 100 different protocols we are parsing, including all relevant database, data center protocols, HTTP, SMTP, HTTP, of course, right, and many, many others. And for all of those threats that we are covering, you also see where those threats are coming from. And also, you can individually configure those threats to be blocked or forwarded via email or syslog, and then also modify the out-of-the-box policies to different policy definitions for threats. So by default, we are grouping those 13,000 threats into subsets where you have maybe common threats, critical threats, and you see here more information about what's included in these critical threats, for example. You can create and modify this depending on your needs. So you can then sub-select, for example, threats that include only specific applications, only specific services like maybe a SQL database or MS SQL. And then you down-select the amount of threats you are looking for at once. And by the way, you can also create rules that tell automatically select a certain list of threats that belong to a certain list of applications only. So you have done a mapping of which services you have in your data center and which threats and vulnerabilities are applicable to those applications. And you can configure that in this screen here. There's also malware detection, and we have another very good investor in the company, which is FireEye. And with FireEye, we can also send traffic directly to FireEye appliances or to the FireEye cloud. Are you by any chance FireEye customer? Even if you're not, you can just use the ShieldX cloud as a way to submit malware samples if this is, for example, a zero-day attack. Then there's also URL filtering. So in the URL filtering, you can decide what constitutes a bad reputation So in this case, you can say alert me from reputation 51 to 80 and 81 to 100. Start blocking those attacks, those classes of URLs. There's 83 classes of URLs. You can import your own. You can also black or whitelist policy. So based on this, you can create your own set of security policies and then apply the set to a group of objects. And this group of objects can again be now very dynamic. This can be based on tags, based on networks, based on workloads. And you can craft your own ACL policy that now spans across your multi-cloud environment. What I'm showing here now is I have a single ACL policy that spans now two VMware environments and an AWS and an Azure environment. And you have multiple different ACLs that are now based on tag-based groups, that are based on network-based groups, and even a quarantine group. So if you have certain VMs that are infected, you can tag them with a certain tag, and then they move directly into the quarantine group, and then all access is denied out of the box. Yeah, so in general, we have certain security controls that we partner with, for example, with the FireEye malware detection engine. So if our malware detection engines do not know about a file, we can submit that to the FireEye cloud, and you don't need to be a FireEye customer for that. You can go through the ShieldX cloud where there's multiple levels of scanning happening, and then we detect zero-day attacks either through the FireEye submission or through the ShieldX cloud. The other thing is our threat detection engine comes from ShieldX. So we have implemented our own malware detection engine and threat prevention engine, but the threat feeds are coming from certain third parties. So we have feeds from TELUS Labs and others, and we are incorporating them into our engine. So it's much superior engine than just using Snort, Pro, Suricata. It is actually a third generation DPI engine that just understands the threat feeds from other third parties. So if you have a threat feed, for example, we can look into accommodating that as well. So the different accounts are handled in the infrastructure connectors, and I jumped over this pretty quickly. So if you look at the different connectors, there is access keys, there's a secret key, and so these to identify actually the account that has access to certain subscriptions. If you have multiple accounts, then you can just create multiple of your infrastructure connectors. And the second question was around Lambda and other infrastructures that are not just IaaS. And we discover not just infrastructure as a service, we can discover any cloud object. So right now, IaaS is our main focus, but we can also see traffic that comes from, for example, a FAS to an IaaS or to a PaaS and so on. So you can insert us in different modes as well. If you go to this grouping and insertion page, we have the ability in public clouds to insert in multiple different ways. And if we go to maybe Azure, there's a way to insert us between, for example, a load behind a load balancer, and then apply NAT rules. So you can insert us in many different ways to accommodate for these new ways like PaaS, FAS, and so on. So you can insert us in this case, depending on the region, depending on the VNet, you can specify an outer load balancer and an inner load balancer, or just an outer load balancer and then NAT forwarding rules. So there's probably another session that we can where we can show you exactly how those different insertion modes will work. Yeah, I'm just showing here Azure and VMware, and you see each individual VM popping up here. So as these VMs come up, they'll pop up in your infrastructure view, in the discovery view. This does not show you yet the threat. So this initially doesn't show you any connectivity. It just shows you which subnets you have, which VPCs you have, and then which VMs are in there. Okay, let me show you this. It took a little longer to load. Maybe it took longer to load than this is the graphical view that shows really everything that's connecting into that environment. And this formulates the basis for machine learning algorithm, where you can say, okay, each individual dot here is representing an object in your multi-cloud environment. And it doesn't matter if this object now resides in AWS, in Azure, or ESX. It shows up in a logical view where you see logical connectivity. And this sometimes becomes very useful already, just to see all these focal points where tons of objects are connecting into. It's also searchable. And if you want to see more about how we define then groups, you can also go into resource grouping. And in the resource groups, you then see the individual connections also between two groups. And this shows you then even the ACLs, where the ACLs are represented on the bottom here. And they are formulating then the recommendation of which ACLs to automatically let us generate to facilitate these groups to communicate.